স্যার মানে আগের ক্লাসে বলছেন গত সেটা নাই
Okay. This or this yeah, so that he or she informs me about required handouts, then I'll see. Okay.
আচ্ছা স্যার
Okay. The main thing is that we have been discussing about the physical factors. Physical factors, and you all know that physical factors are the weight. আচ্ছা কি করছে কেন তো তোমাদের কারো ওখানে সবার মাইক্রোফোন গুলি বন্ধ করে দাও, তোমাদের গুলি মাইক্রোফোনটা বন্ধ করে দাও, আমার এখানে মাইক্রোফোনটা অন রাখছি এবং ভিডিও অন রাখছি। না এখন ঠিক আছে। Could you hear me?
Yes sir.
Okay, that's fine. Now it is clear. Now it's clear. Very good. So yesterday we talked about a very important aspect of the aquatic ecosystem, that is the mixing and stratification. And this mixing is important in that case because it brings all the nutrients of the water come up where the phytoplankton lives, and those phytoplankton then ও জোরে কথা বলে হবে না, সরি। আমরা সবাই একসাথে মানে আমরা জুমে ক্লাস করছি, একটু ডিস্টার্ব হয়তো দেখে হতে পারে। So in this picture we see the different kinds of please locate control. You see that's a plotting, and this is the degrees of latitudes, and this is the altitudes, and all the aquatic ecosystems having different mixing condition are shown here, and you see that all these emictic, that means there is no mixing condition, all these are situated in higher altitude. Higher altitude means at the top of mountain mostly, and there is the cold polymictic, and it occurs in between 80 and 70 degree latitude. Then you have a 70 to 6 degree latitude, and then you have dimictic, and you have one monomictic, and these are the polymictic. So with this you can, these are the oligomictic, that is coldly mixed, many times mixed, warm single time mixed, two times mixed, cold one time mixed, and no mix. So this is a global distribution of different kinds of lakes with mixing condition. Now our question could be where is the position where our country is located. So Bangladesh has a latitude 20 degree, 26 degree, and so it should be somewhere in between here. So in most cases our deep water bodies, one monomictic or oligomictic, you must appreciate that since Bangladesh is a very shallow country, deltaic country, it has got no alpine lakes, only few lakes, two lakes are present, that is the Boga Lake and the Rhine. And this Boga and Rhine, they could have either one monomictic or oligomictic situation, and all the surface waters which are present in Bangladesh, if closed water body, if they have a water depth of lesser than 10 meters, then they will not show this profile. So only the water bodies, closed water bodies, that is ponds, lakes, and so on, having a depth of more than 10 meter, then uh, they could show this kind of mixing pattern. So we have seen here the distribution of different lakes throughout the global latitudes. So now there is another kind. We have seen otherwise that the dimictic, warm, cold monomictic, warm monomictic, and so on. But here is a meromictic. Mero means partial, and mictic means mixing. So meromictic means partially mixed lakes. Partial. Partial means the only a part of that water body becomes mixed. The all other places are never get mixed. So there is a permanent stagnation in those cases. So what is written here? All dimictic lakes holomictic because undergo complete mixing. Besides, there exists another group of lakes which water never mixes. That is top mixed layer separated by steep density gradient known as chemocline, beneath which remain non-mixing layer monomolybdenum. We have already seen that temperature could create this kind of situation. That is, under thermal stratification, no water mixing takes place. But in this case, it is not the thermal stratification, but it is a kind of chemical stratification. So we all know that temperature and dissolved substances can only affect density of water. So in this case, they dissolved substances they affect the density of water, and as a result, there occurs a stratification. You see here, it is a stratification, and whenever we call stratification, it means that the concentration of that particular uh, component is different at different depth. So you see that it is plotted here, the concentration, and it is different. And same is the condition with all the figures. So this type of lakes, that is, the water will mix only from this place to that place. But under this region, there will be no mixing. That is this part. So you can easily understand that a huge volume of water remains unproductive because the water does not mix, the nutrients are not evenly distributed, and that's why they show very less productivity only in the upper zone. So you see in this case, this area is mixing, in this case this area is mixing, here this area is mixing, here this area is mixing, here there is absolutely very little area are mixed. So besides the dimictic lakes, that is the lakes which are more two time mixing, we also get a special type of lake ecosystem that is called the meromictic or partial lake, and that is usually formed because of the chemical stratification, and this is called the mixolydian, and this is the bottom of this part monomolybdenum. That is, monomolybdenum means the mixing is absent in this layer. So I think the basis of this kind of lake ecosystem you understood. So for this, why it occurs? We have said dimictic lake, and dimictic lake is purely because of thermal stratification and overturn processes. But overturn processes. Sorry, ওখানে তো একটু কথা কম বললাম। Causes. Why occur? Diffusion of saline water is fresh water. You all know that saline water has a higher density. So at any depth of a water body, if the water gets incorporated, then the water with the higher density water will be stored at the bottom, and the lower density will remain above that. So that will create non-mixing zone, and absorption of minerals by bacterial plate to deeper water layer. And if you have a very high concentration of bacteria at a depth of at a certain depth of water, and you all know that bacteria are minute particles, and that's why if they a thermal stagnation, or there is a bacterial plate which absorbs amount of heat, and that they are actually gives a protection for mixing. Intrusion of spring water with high conductivity. High conductivity means any water having high electric conductivity indicate that many salts are involved in it. So if there would be any spring ঝর্ণা, সেই ঝর্ণা যদি একটা ডেপথে মনে করো পানি আনতে থাকে যার কন্ডাক্টিভিটি ভেরি হাই, তাহলে কি হবে, সেই ডিপার রিজনে ওই হাই কন্ডাক্টিভিটি তো পানি সবসময় একটা ব্যারিয়ার হয়ে থাকবে, তার নিচের পানিকে কখনোই মিশতে দিবে না। সুতরাং এইভাবে তোমার মেরোবিং প্রসেস শুরু হয়। লেক টকি অফ নরওয়ে remains merovingic series for 6,000 years. So you see that this is quite unique. In Norway, there is a lake, the name of which is Toki, and that lake has been remaining under merovingic for 6,000 years. So the problem of merovingic is that the lake becomes really unproductive. Don't get any fish, don't get any primary productivity, and don't get also the plant production in the merovingic lakes. But if the production occurs, that is very little compared to the water body. There are three types of merovingics: ectogenic one, and then crenogenic and biogenic. So ecto, the term ecto means outside, and genic means generic. So if the merovingics occur because of any outside region, then it is only ecto. So it occurs due to external reasons. This tidal upsurge in coastal regions, saline water enters into fresh water, and so on. So you see that if there be a lake situated near the coastal region of ocean, and under high tide, or because of the tidal upsurge, if salt water enters into fresh water, then this kind of merovingics is called. And application of salt in highways for de-icing during winter season because merovingics in lakes adjacent to highway. এবং তোমরা জানো যে in temperate countries during winter the roads become slippery because of ice formation, and for that ice lot of salts are sprayed so that the ice becomes melted, and the road becomes clear for traffic movement. So under that condition the merovingics also occur. That is the salt, huge amount of salt which are applied for de-icing all those seaways that reach and enter a nearby lake and merovingics. So ectogenic merovingics is caused by seawater intrusion or the saline water intrusion because of de-icing. And this is crenogenic. Creno means spring, and genic means genesis. So any merovingics which occur because of the spring, then it is called crenogenic. Spring water containing minerals emerges in different part of lake may cause merovingics because density of such water will be higher and make barrier existing. So it is quite easy to understand that any lake is present at a certain depth of water, and if that spring brings salt water or water with high conductivity, that cause partial mix, and this is called crenogenic. And biogenic, bio means the living things, and genic. So if your merovingics occur because they occur, then it is called biogenic. Salt minerals released by the composition of four primary factors in handling of lakes produce means if you have a very activity in your lake, then this production which is created at the topmost layer after their death, they die to certain depth, and in those depths decomposition occurs and lot of minerals are set free, and all the minerals form a barrier to the water layer, and that's why you cannot sometimes bacterial death, as I have already told you that that bacterial death Europe, it has been seen that the lake is aerobic, but after adding water from a depth of 80 meters, it was the water was fully blood red in color. So at such a depth, the spectacle cannot occur because there is very little light. So what happens, because our condition, lot of bacteria actually growing there and making a lighting. And if the organisms absorb, heat, then the irrigation or the aerobic system falls. So the aerobic thing they be classified in type in biology. So we have so far discussed number of factors. Now we should come another one that is called control. So this is definitely a very important factor for the plants which are going in water. Why? Because this water movement actually carries nutrients from one place to another, and it also creates lot of other facilities to the nutrient absorption. Where, for example, help distributing biogenic gases in the epithelium. Biogenic gases and minerals in the epithelium. Water of lakes, house, bowls, ponds, etc. are not stationary. We all know that, and if we start go to visit any of these places, then we might see that the water is moving to a certain extent. Sometimes water movement is visible as waves. আমরা বেশিরভাগ ক্ষেত্রে পানির যে মুভমেন্ট সেটা ঢেউ হিসাবে বা স্রোত হিসাবে দেখে থাকি। কারেন্ট ওয়েভস নট ভিজিবল। ওয়াটার বডি মে বি স্টিল বিকজ অফ, আমরা হয়তো মনে করো একটা লেকের পাশে গিয়ে দাঁড়ালাম, কিন্তু দেখি যে পানি একদম শান্ত অবস্থায়। Doesn't mean that it's not moving. The fact is not like that. The fact is still the water could move because of the convection current. And you know that the water must absorb heat, and these differences of heat absorption at different places would create a convection current. Create a convection current. So what occur by waves, currents, and also convection currents may occur because of the particles. Primarily, wind is the main force for the movement and mixing. Besides, water temperature and density also responsible for some sorts of water movement. And you all know that if your high dense water is top and low dense water is bottom, then this high dense water all will be trying to sink down, and it will cause some sorts of water movement which are not visible by our naked eye. Only by putting instrument at the depths of water body, they measure this kind of convection current. Wind and density jointly affect water and produce biological and chemical gradients in it. That we already know that wind and water density actually jointly they could work and produce biological and chemical gradients. So now we should see the flow of water. Flow of water dependent on basin morphology slope, of course. Basin morphology, how the basin morphology is created, that is an important factor for water flow. If the roughness of the basin, if the basin is too rough, the flow will be a different one. If basin information, basin topography is little rough, then those two are complicated. If water flows on a smooth surface, uninterruptedly called laminar. So if you just put some water on a glass sheet, then what will happen? The water will flow flow without having any disturbance from the surface, and that is called laminar flow. That is, laminar flow occurs where your basin morphology and topography is almost smooth. Water flows onto rough surface, though resistant wave will produce called turbulence. But if the water flows on a rough surface, then the water gets turbulent, and the flow is also resistant. Turbulent flow forms vortex. It is cause mixing of nutrients gases in water. So you see that these are the turbulent flow, and the surface waves are manifested in all these in all these positions. And you see that vortex are formed. Vortex is the spiral end of the wave. Waveর যে spiral end থাকে, সেই spiral endটাকে আমরা vortex বলি. So you see that this is the creation of the vortex, and this is the full creation of the vortex. So how it helps water body, you can easily understand that if this would be your atmosphere, where all the biogenic gases are present, that is the oxygen, nitrogen, carbon, hydrogen, all are there. So that gas actually enters into the spiral of the body, and when all this vortex becomes I mean disappears, then the gases trapped in all those spirals, they get dissolved in water. So this is a very interesting phenomenon, particularly in lakes, for the dissolution of biogenic gas. And for biogenic gas, we all know that it is the carbon dioxide and the dissolved oxygen. These two gases are highly important for all sorts of organisms. Oxygen is needed for the respiration for all sorts of aquatic organisms, and carbon dioxide is needed for plants to make photosynthesis. So this process, that is the making, the formation of vortex, এখানে vortex তৈরি হচ্ছে আরেকটু বেশি হলো, এখানে নোড ফর্ম করলো এবং নোডটা তখন স্পাইরালে পরিণত হলো, and all the gases are then trapped inside the spirals, inside spirals, and then it gets dissolved in alumna. Sorry. Uh, uh, so, so all these the gases then get dissolved inside water, and that happens because of the vortex formation. Reynolds number. This is a figure, and calculating Reynolds number events laminar or turbulent flow of water could be detected. It means turbulent and water detected. So RE, that is the Reynolds number. So by calculating the Reynolds number, we can say that laminar flow and turbulent flow. We have so far studied the laminar flow and turbulent flow. That is, if you have a very smooth glass-like bottom, laminar and turbulent. So now if you are asked how we could determine the Reynolds number, then there is a process, and that process is that the Reynolds number RE, which is equals UD over P, where E equal to velocity of current, V equal to water depth, and V equal to kinematic viscosity of water. So if you have all this information, then after calculation you get a value at RE. So Reynolds number goes below critical value, that is RE 500, then laminar. So if we, after calculations with this kind of data, that is U, which is the velocity of current, V equals depth, and equal to kinematic viscosity of water, এই তিনটা জিনিস যদি আমাদের হাতে থাকে, তাহলে আমরা এই তিনটাকে এই সিম্পল ইকুয়েশনটা সলভ করলে উই গেট রিভার্স নাম্বার, এবং রিভার্স নাম্বার যদি আমার 500 নিচে আসে, তাহলে বুঝতে হবে এটা ল্যামিনার ফ্লো, 500 উপরে গেলে এটা হবে টার্বুলেন্ট ফ্লো। সো value of Reynolds number greater approximately 2000, then calculate. As for example, in one leg, value of U equal to 10 centimeter per second, and then D equals a meter, and then you have a V equal to over 1 centimeter square centimeter per second. So this is a simple equation that R equal to UT, R equal to UT over V. So we have a value U, we have a value we have a value V, and we have a value AD. We have a value here in this equation U, V, and V. So if you put this in this equation as I have informed you earlier, then you get a value R equals 10 to the power 6, which is much higher than 2000, and therefore it will start. So I hope now you understand what is Reynolds value. Reynolds value actually gives you the information whether your water body is under turbulent flow or it is under laminar flow. And by using that simple equation and the data relevant to components of that equation, you could easily calculate the Reynolds value. So what Reynolds value now you understand. So now another we find another another thing that is called sea chase. Actually, it is a French word. SIEC chase. This is not a Latin word, English word, but it is a French word. It derived from French sichi, means dry. Designates dry area formed due to fall and rise in water level. Say, for example, you take some water in a huge bowl, and if you just make that bowl, if you just shake that bowl, or if you just um, drop one side of the bowl, and the other side will raise. So under this condition, what will happen? Your water inside the bowl will just move like a minute. The strength of sea change in your plane. And now is the land room circulation. Land room circulation is very important. It is the lines of foam or wind roll in the same direction and right angles to waves. এটা খুবই একটা ইন্টারেস্টিং বিষয়, এবং আমরা যখন অনেক বড় নদী বা লঞ্চে নেমে থাকি, তখন আমরা অনেক সময় দূরে এইরকম ফেনা ফেনা মানে এক ধরনের হোয়াইটিশ কোয়াগুলেন্টস এর এরকম সারি দেখতে পাই। Actually, those those are for the language circulation, and language spirals are created because of the at the wind direction. And you see that one spiral is in clockwise and another one is the clockwise. So if two cylinders moves, one is anti-clockwise and another one is clockwise, then lot of mixing will be occurring in it. And this kind of movement is actually called language circulation. These lines mark boundary the pairs of language spirals, series of adjacent particle clockwise and counterclockwise rotating cells of water. So this is just like this one. This one is just like a cylinder of moving water anti-clockwise, and this is the cylinder of moving water clockwise. Again, it has got a unique set of similar pair of cylinder. So এই স্পাইরালগুলি যদি সামনের দিকে এগুতে থাকে আর ঘুরতে থাকে তাহলে there will be lot of mixing of water, and this type of mixing is called Langmuir circulation. So these alternate areas of upwelling, downwelling. Upwelling and downwelling বলতে আমরা এইখানে এইটা এই যে নিচের থেকে পানিটাকে উপরে নিয়ে যাচ্ছে, যাওয়ার পরে এটা আবার নিচে যাচ্ছে। প্রত্যেকটি সিলিন্ডার ওই একই কাজ করছে, কিন্তু একটা সিলিন্ডার ক্লকওয়াইজে করতেছে আর একটা সিলিন্ডার এন্টি ক্লকওয়াইজে করতেছে। সুতরাং একটা পানির সমতল দিয়ে যখন একই দিকে বাতাস বইতে থাকবে তখন this kind of language circulation will be occurred. So I think you understood the whole issue of language circulation. Windows also called slicks. এই জিনিসগুলি এগুলিকে বলা হয় slick, SLIC. So windows also called slicks contain algae and oily substances or natural events from death and decay of plankton shoreline vegetation. So why this forms form? Because on the water surface, lot of some materials get accumulate. So if you have a fatty substance, if you have a dead plankton, if you have some other components contaminated from outside, then all this with this mixing action, mixing force, actually forms this kind of windrows. So windows are also called snakes, contain algae and zooplankton as well as oily substances or natural foaming agents from death and decay of plankton or shoreline vegetation. So all these debris particles, they can accumulate in water and could carry out the formation of this kind of foam. So you know why windows are formed and why we can see in the surface of a large water body this kind of rows of foams, and these are formed because of the debris and other substances which are present in water. Langmuir type of circulation due to interaction between surface waves and wind-driven wind currents. So all these are physical forces, and these physical forces affect in a number of ways the biology of water. It can affect the animals. It can also affect the plants, and particularly in those regions the plants are microscopic planktonic organisms. Those all are affected by this kind of language circulation. So okay, language spirals. Spirals produce major downwelling flows between 2 and 8 centimeters per second. That is actually the force of mixing which is created by Langmuir circulation, that is 2 and 8 centimeters per second. That is the force. That is the force of mixing, and considerably faster than swimming of most low plankton or algae. সুতরাং এই যে 2 থেকে 8 সেন্টিমিটার পার সেকেন্ডের যে ফোর্স, সেটা সেটা অনেকটা জোপ্ল্যাঙ্কটন এবং অ্যালগি যে পানির ভিতরে মুভ করে তার থেকে অনেক বেশি। ল্যাঙ্গুড স্পাইরাল মে র্যাপিডলি মিক্স plankton, heat or dissolved gases throughout equilibrium. So you can easily understand that um, if two spirals, one is moving clockwise and another moving in anti-clockwise, if it works on the surface of water, lot of mixing of and lot of dissolved oxygen get incorporated into the water. So in this way, actually our water system gets dissolved oxygen, free carbon dioxide, and also other vital particles inside the water. So these are the mechanism by which the water body actually becomes fertile and then productive. যে পানিতে কিভাবে পুষ্টি উপাদান আসবে, দ্যাটস দ্য বিগ কোয়েশ্চেন। আমরা তো সব পানিতে আমরা পুষ্টি উপাদান দিই না, আমরা শুধু কালচারাল পন্ডে পুষ্টি উপাদান দিই মাছের প্রোডাকশন করি, কিন্তু আমরা বড় বড় যে ওয়াটার বডিগুলো আছে তাতে আমরা পুষ্টি উপাদান দিই না। তাহলে পুষ্টি উপাদান কি ভাবে আসে, সেই প্রশ্নের উত্তরটাই আমরা এতক্ষণ ফিজিক্যাল কোর্স হিসাবে ইয়ে করলাম, আলাপ করলাম। তো actually language circulation gives a lot of brings a lot of beneficial to the organisms, and at the same time the language circulation could also be devastating to the organism. এটা ক্ষতিকর হতে পারে কিভাবে? Daphnia may concentrate in slates, presumably offsetting disadvantage of being eaten against advantages of concentrations of food in the form of algae and bacteria. So ড্যাপনিয়া অ্যাকচুয়ালি স্লিকের ভিতরে অ্যালগি এবং ব্যাকটেরিয়াগুলি আটকায়, এবং অ্যালগি এবং ব্যাকটেরিয়াগুলি স্লিকের ভিতরে যদি আটকে যায়, বিকজ দেয়ার ইজ টু কাইন্ডস অফ ফোর্স, ওয়ান ইজ অ্যান্টি ক্লকওয়াইজ অ্যান্ড অ্যানাদার ওয়ান ইজ ক্লকওয়াইজ। সো যদি ওই জায়গাটায় যদি কোনো অর্গানিজম চলে আসতে পারে, আমি আপনাদেরকে দেখাই আর একবার একটু এই যেগুলি, এই জায়গাটায় যদি কোনো অর্গানিজম চলে আসে তাহলে তার আর এখান থেকে সরে যাওয়াটা সম্ভব, কারণ টু ফোর্সেস আর অকারিং হিয়ার। মানে অর্গানিজমটা তোমার এই জায়গায় একটা এন্টি ক্লকওয়াইজ, এটা হলো ক্লকওয়াইজে ঘুরতেছে, কাজে সেইখানে যদি সে কোনোভাবে পতিত হয় তাহলে সে এখান থেকে আর বেরোতে পারে। এবং this fact actually causes a lot of changes in the food chain, that is offsetting disadvantages of being eaten. সুতরাং ওই ফাঁকের ভিতরে যে সমস্ত অ্যালগি এবং ব্যাকটেরিয়া আটকা পড়ে যাবে তাদেরকে খাওয়ার জন্য ড্যাফনিয়া হলো জোপ্ল্যাঙ্কটন, কিন্তু ড্যাফনিয়া খাবার ওইগুলিকে গ্রেস করবে, কিন্তু সে ওখান থেকে বেরোতে পারবে না, কারণ বিকজ অফ দিস কাউন্টার অ্যাক্টিং ফোর্স। সো হোয়াট উইল হ্যাপেন, ফিশ উইল নো that in the slicks there will be lot of food. তখন ফিশ ভালো করেই জানে যে এই স্লিকের ভিতরে প্রচুর জোপ্ল্যাঙ্কটন, ফাইটোপ্ল্যাঙ্কটন এবং ব্যাকটেরিয়া আছে। So by utilizing that intake, actually fish would raise down all the plankton in the sling, and fish has got a stronger movement capacity than Daphnia. So the Daphnia population would be depleted inside the sling. So this is very clear. Inhibition of algal photosynthesis by exposure to sunlight intensity, well known, and rapid mixing of languid spirals may increase light inhibition and reduce primary production. So what happens to the phytoplankton if they are trapped inside the sling? Because they will lose their photosynthesis. The light will be lower because the slick layer is concentrated with lot of foams which cuts light, with lot of debris particles which cut off light, and so on. System of water suspended at fixed depth normally used to estimate photosynthesis may not produce the natural light regime. So if you then at the same time, if you just carrying out the oxygen measurement procedure, then you will see a completely different data, and that happens because of the language circulation. Now movement in the thermocline, water in the thermocline. So we have told very strongly that the water of the movement cannot, water of the thermocline cannot move. But is it the fact? The fact is not like that. It sometimes also can go under mixing because of molecular addition of water. only hope of water movement in the zone molecular division, that is the molecular movement. You all know that all compound they do have this kind of movements, and this because of this movement the molecular division occurs. And if we cannot help to recover sudden fall of oxygen due to zooplankton water movement zone, but weak process if we cannot help to recover sudden fall of oxygen due to zooplankton respiration. But this kind of molecular division could create only a very weaker concentration difference, and weaker difference in concentration. Stagnation attacks some microplankton, bacteria, and zooplankton to colonize. And since the area becomes stagnant, so it has got a stable physicochemical conditions, and by utilizing that, actually zooplankton, microplankton, and bacteria would concentrate. New gradients of nutrients essential minimized by slow resonance internal thermocline. So sometimes the new gradients are important because you know that if phytoplankton starts making photosynthesis at a place, then after certain time the uptake concentration will be equal to the concentration present in water, and if the equilibrium occurs, then there will be no uptake process. So to initiate uptake, the organisms will have to find a new environment, and that is caused in this kind of slow-moving area. Water of thermocline can also move by internal gravity waves and shorter time internal gravity waves. So there are signs of waves you will be observing that, and those smaller movements can also help organisms. That is the movement of water in the hypolimnion. Since the hypolimnion water remains always in a sink and stable, so they have a very little movement, and the physics of water has differentiated two different kinds of water movement there. One is the Kelvin and Poincare wave and molecular division, as we have already discussed before. So you see that this is the thermocline. This is the thermocline, and apparently we can say that there is no movement. But you see that there are some oscillations inside the thermocline, and these oscillations could be seen only by keeping a very sensitive instrument. We can find this kind of oscillation. So if though it looks like a straight line, then there is no oscillation here, but actually it apparently looks like. But after many resonance values, then we can find that actually in thermocline there are a lot of finer diffusion of water molecules from one place to another. So we can now conclude that actually this whole water remains under moving condition, not stationary condition. There would be some very strong wind, and there will be some very low wind, and so on. So we have now finished our 4 number lecture. We should now go to the 5 number lecture. Ask. Association of the living organisms in natural water, call them conjugate. So why natural water? Why organisms will be living in the natural water? The causes we have already I mean the reasons for which the natural water will be will be occupied by living organism. আমরা সেটা আলাপ করেছি, তার ভিতরে আমরা ফিজিক্যাল অ্যান্ড কেমিক্যাল একটা পেয়েছি। তো সেখানে কি ধরনের অর্গানিজম বাস করে এবং তার কারণগুলি কি, দ্যাট উই শ্যাল বি স্টাডিং নাও and we shall be observing now. So natural water known devoid of organisms, their ecosystem function first discovered by Hume and Hobbes. They are two German scientists, and long before it was actually known that our water body are our water body are full of organisms. And then open natural water support some organisms known. The questions why and how answered later on through results or results. So why the organisms they colonize the natural water and how do they colonize? The answer of these questions actually is research based, and after carrying out a lot of researches, actually these we know clearly how and why the organisms they colonize the water. Like in freshwater, organisms in freshwater systems live first high density of water, lack of salt in freshwater, high solubility of water for inorganic and organic materials, and development of vertical profiles in water. So these are four reasons which actually are reasonable to support organisms in water because of the density function and lack of very high concentration of salt and also high solubility of water for inorganic and organic materials. So the whatever water we collect from nature, that contains lot of organic and inorganic material, and also development of vertical profile. Actually, because of this vertical profile development, different kinds of microhabitats are grown, and so that allows a diverse organisms to কোনো মনে করো যে মাইক্রোক্লাইমেটিক কন্ডিশন যে তৈরি হয় বিকজ অফ দি ভার্টিক্যাল gradient. Say for just consider light. So একটা ওয়াটার ডেপথে যদি একটা কোনো অর্গানিজম যদি বেশি লাইট পছন্দ করে তাহলে সে উপরে থাকবে, আর যে কম লাইট পছন্দ করবে সে নিচে থাকবে। কেমন? এটা একটা সিম্পল এক্সাম্পল। তো অ্যাকচুয়ালি দিস ভার্টিক্যাল development of vertical profile actually creates a lot of microhabitat, and by utilizing each microhabitat, each organism to grow, and this process we actually get a bigger diversity in organisms in the aquatic habitat. And we all know that diversity is an important issue for an optimum production of in case of aquatic habitats. Effect of water density. So how water density affects organisms? Water density 775 times more than air. Organisms in water will sustain increased biology effect for the specific gravity of organisms being only slightly higher, 1.05 than 1.05 than water. Therefore, water capable of supporting organisms very well. সুতরাং those organisms which live in water, they have to sustain a very high pressure from the water density. Having two consequences, the interface base of water can be permanently colonized by organisms, supporting tissues or organs necessary used instead to assist forward motion movement in water requires more energy than air because hydraulic resistance increases with density and viscosity medium. So this density actually produces effects in a number of cases. Effect of low salt content. Tissues and body fluids of freshwater organisms contain high concentration and different composition of electrolyte compared to ambient water. Of course, the tissues and body fluids, they do have a different concentration of components and than the ambient water. Ambient water means in the water where they remain immersed, and there are two kinds of things, hypertonic. So electrolyte composition is constant, adapted for osmoregulation and ionic regulation. So this their adaptation, the organism's adaptation must go through osmoregulation and also the ionic regulation. Following abilities of freshwater animals, what are the abilities? The abilities are excretion of large amount of salt, low salt, organic or urine and renal desorption of electrolytes. So to balance with the concentration of salts in ambient water, actually the organisms they in their urines they actually excrete a large amount of urine. So a reduction of water inflow by means of water impermeable membranes. So you all understand the role of semi-permeable membrane which are present in the body of all organisms, and by utilizing that membrane they keep a balance of salt and nutrients inside the body. Secondly, uptake of electrolytes from water against concentration gradient via chloride cells, and some of them they have a special kind of cells which is called chloride cells, and by utilizing those cells they actually maintain a selective uptake of electrolytes. And derivation of salt supply in part from food intake. তারা লবণ পায়, সেই লবণ অ্যাকচুয়ালি দেহের ভিতরে সঞ্চয় বা বের করে দেওয়ার মাধ্যমে তারা এই পরিবেশের সাথে তারা খাপ খাইয়ে নেয়। Effect of high solubility. Water universal solvent and dissolves solids, gases, and distributes those from one place to another through external and internal flow. You all understand that because of the external and internal flow in solids, actually they maintain this kind of balance. Can also create horizontal vertical gradients while solids result creation of free microenvironments, a single water body. So this kind of creation of this kind of microenvironments I have already informed you. So all this actually help live or all this actually help the organism live in the aquatic medium. Besides organic and inorganic substances released by organisms due to their solidity in water, reintroduced material cycles. So, effect of vertical profiles. Vertical profile যে তৈরি হয় পানির ভেতরে, সেই প্রোফাইলটা কি প্রভাব হলো ভার্টিক্যাল গ্রেডিয়েন্টস ইন রেসপেক্ট টু হাইড্রোস্ট্যাটিক প্রেসার, টেম্পারেচার, ইলুমিনেশন। চারটা কারণ সেখানে ঘটতে পারে। একটা হলো হাইড্রোস্ট্যাটিক প্রেসার, দি ওয়াটার প্রেসার, তারপর তাপমাত্রা এবং আলোর প্রবেশ্যতা। এই কয়টা জিনিস সেখানে ভার্টিক্যালি ডিফারেন্ট হতে পারে। অ্যাজ ওয়েল অ্যাজ সেকেন্ডারি ফ্যাক্টরস অফ কেমিক্যাল নেচার divide water mass into objects into patchwork of different modes of varying degrees of attractiveness for aquatic organisms. This part I have already varying degrees of attractiveness for aquatic organisms. I have already informed about the vertical profiles and creates a lot of microenvironment. This implies a distribution of life in water body as well as periodic migration of many organisms between water bodies of differing water quality. So actually uneven distribution of life in water body as well as periodic migration of many organisms between water bodies and different water bodies. So which happens because many organisms they search their food and for searching their food, they sometimes migrate from one place to another. Say for example, the dimension of the zooplankton actually that causes a lot of changes inside the water Subdivisions of lakes depending on life in freshwater. So, এই যে আমরা distribution of life এর কথা বললাম, which depends upon a number of factors and characters. In vertical distribution of life এর উপর ভিত্তি করে how we could classify what a body that we are going to subdivision lakes depend on freshwater organisms. Pelagic, the lighted area. You can say pelagic is the free water lighted. এখানে all algae, bacteria, invertebrates, primarily Lathocerans, copypods, all grow in the pelagic region. Their protein action combined with swimming in rivers, self-sustained motion of plankton, all are insignificant against the water. And you can have a clear view of the organisms, and you see that these organisms are actually shallow water loving organisms, and you see they start from very beginning of the shoreline, and they gradually go to the part of the water, and you see this is the Tara plant, Tara algae, and they are all endosperm. So why those at the end? Because it can carry out photosynthesis at a very low height. So this plant cannot, if this plant is put at this stage, it will die. But if Tara grows here, then it will survive. So this actually gives the unique distribution of the littoral. And these are the pelagic plankton. Here you don't find this kind of plant, you find the microscopic plants which are free living in the water, and they are all pillars. And carry out high density and resources is an important characteristic for adapting on this kind of product. Tara vision তাদের density and natural term আগে যেটাকে and all have got upper zone not affected by water, spray zone only affected by breaking waves, and ulittoral where occasional সামারের সার সারগুলো আমরা দেখেছি অনেক পরে ভেঙে একদম পানি আসে, সেই যে সব আমরা সুন্দর এই ধরনের সার দেখতে পাই। তো এখানে সার এখানে যেহেতু হাই ফোর্স আছে, so most of the body area, and they can also sometimes hide inside the stones or needles and catch from alternating movements of water and similarity to water. So they have a lot of mechanisms to cover this kind of unwanted situation created by SARP on the SARP and other kinds of movements. They can hide inside stone and leave in sand and stand strong alternative movements of, and infrared bank zone colonized by higher plants may be subdivided reed belt নলখাগড়া পানি দেওয়ার সময় দেখবেন যে নলখাগড়ার একটা কমিউনিটি তৈরি হয়েছে, which is composed of Shivleka, which is Jaiva, and so these bed of protein plants of various nucleaceae with some protomotor mediophyllum and ceratophyllum, etc. So what happens there is a clear demarcation. In the reed bed, you get this fragmitis and part of the basis you find the momentum and ceratophyllum. These group do not grow here, and these group do not grow here. So that the clear demarcation of reed belt area. And you see one of the reed belt in a European lake, and you see huge row of Phragmites australis here in this place. And you know that these kind of fish are very common in many parts of Europe. And this is the lake, and you see the reed belt is there. And now there are some why reed belt in the reed, why aquatic plant grows in water, and which kind of adaptation they possess. And you see that aquatic plants growing in aquatic environment, they must have this kind of lacunar development. That's the air space, and with the help of this air space, they can encounter the waterlogged situation. That they can reserve the vital gases inside this lacunae, and they can sometimes use these storages for their photosynthesis and respiration. So uh, actually, this will be the last slide. I have an important program. I have to leave today after explaining this slide. So under which mates for principally of anti-aggressive and literal zone in marginal fundal zone, where only few faint light algae can still continue their net production activity. So you see that these places have got different varieties of plants, and by this factor, different kinds of organisms. Besides aquatic algal community, it has to subsets also growing hydrograph. It sometimes can be seen that the submerged stones and submerged objects, they can also support a special kind of organism. Those are called periphytons, and among those, the freshwater red algae Hydrangeia, Santhentia, Batrachosata, all grow in that condition. And among animals, the organisms nematodes, rotifers, chironomid, fly larvae, and also grow there. So, students, I'd like to leave for today. So maybe we'll be meeting in the next week. Okay? Please.
Yes, sir.
আজকে কি দুইজন মনিটরই আছে?
শুধু আমি আছি স্যার।
তুমি আছো? তুমি ওই স্ক্রিনশটটা আমাকে দিও।